Hello students, today's question is the which is not a redox reaction, among the given below they are given. Now, first of all, coming to redox reaction. What is the redox reaction? Redox reaction means in which reaction both oxidation and both oxidation and reduction takes place, then it is a redox reaction. So now oxidation, how to identify? So oxidation means what is that? That is the increasing in oxidation state. Then it is a oxidation. Next, reduction means there is a decreasing in the oxidation state, then it is a reduction reaction. So both oxidation and reduction takes place, then it is a redox reaction. So first, what is the option A? That is the 2 KClO3. 2 KClO3 gives rise to 2 KCl plus 3O2. So this reaction is a redox reaction or not, we have to check. So what is that? 2 moles of KClO3 is gives rise to 2 KCl plus 3O2 they given. So now first of all calculate the oxidation states of each element we have to calculate. So potassium already we know, that is the 1A group element. So 1A group element oxidation state how much? +1. Next, oxygen oxidation state -2. So now calculate the chlorine oxidation state. Here potassium how many is there? 1 plus chlorine we don't know, so put the X minus. Here 3 oxygens are there. Each oxygen, what is the oxidation state? -2. Then 3 oxygens, that is the -6 equals to 0. Then X equal to, this is X minus 5 equal to 0. Then X equal to 5. So this is the chlorine oxidation state. This is. So chlorine oxidation state how much? That is the +5. Next, this side KCl. Potassium oxidation state, that is the first 1A group element, so then it is a +1. So then KCl is a -1. Next, oxygen oxidation state how much? This is oxygen is a molecular state, so that's why it is atomic state. Oxidation state is 0. So now we have to check potassium in the reactant side. What is the oxidation state? +1. Product side also +1, so there is no change in the potassium oxidation state. Now coming to the chlorine oxidation state, chlorine in the reactant side, there is the how much oxidation state? 5, and this side is the -1. So 5 to -1, chlorine oxidation state is changes from 5 to -1 means what happened? Oxidation state is decreased. Oxidation state is decreased means what is this? This is a reduction. Next, oxygen, here oxygen oxidation state how much? -2. Here this side oxygen oxidation state 0. So oxygen oxidation state is changed from where to where? -2 to 0. -2 to 0 means what happened? Oxidation state increased. Oxidation state increased means that is the oxidation reaction. So in this reaction, if you are observed, chlorine is involving in the reduction, oxygen is involving in the oxidation. So both the oxidation and the reduction takes place. So that's why it is a redox reaction. Not a redox reaction they are asking. So option A is a redox reaction. Now coming to the B option, H2 plus Cl2 gives rise to 2HCl. So now check that B option, H2 plus Cl2 gives rise to 2HCl. Now this one is a redox or not, we have to calculate. They are asking not a redox reaction. So H2, what is the hydrogen oxidation state? 0. Why? Because it is a molecular state, and chlorine oxidation state is also 0, molecular state. And here hydrogen oxidation state how much? That is the +1, and chlorine oxidation state is the -1. So now hydrogen from where to where? That is the 0 to 1. 0 to 1 means increased in oxidation state, so that's why it is a oxidation reaction. Next, chlorine oxidation state is changed from 0 to -1. 0 to -1 means that is the decreased in oxidation state, so that's why it is a reduction. So both oxidation and reduction takes place. So that's why it is a redox reaction. Second option is also redox reaction. Now coming to the third option. What is the third option? Cl2 plus 2Ki gives rise to 2KCl plus I2. So this is the equation. Now check it whether it is a redox or not. Option C. What is that? Cl2 plus 2Ki gives rise to 2Ki gives rise to 2KCl plus I2. 2KCl plus I2. So now calculate the oxidation state. Chlorine Cl2 molecular state, chlorine oxidation state is 0. Next potassium is the plus 1. Why? Because it is a 1A group element. So potassium oxidation state is plus 1. Next iodine is minus 1. Next KCl, potassium is the plus 1, Cl is the minus 1. Iodine is the molecular state, so that's why it is a oxidation state is the 0. Next chlorine oxidation state, observe chlorine initially that is the 0, finally it is a minus 1. So 0 to minus 1 its oxidation state is changed. So 0 to minus 1 means it what happened, decreased in oxidation state. So that's why chlorine is involving in the reduction. Next iodine minus 1 to 0, minus 1 to 0 means what happened, increased in increased in oxidation state. So that's why it is a oxidation reaction. So both oxidation and reduction takes place. So that's why it is a redox reaction. So option A and B and C, those are the redox reactions only. Now they are asking the not a redox reaction. So now observe the fourth option, that is the K2Cr2O7. K2Cr2O7 plus 2KOH gives rise to K2CrO4 plus H2O. This is the equation. Fourth one, K2Cr2O7 plus 2KOH gives rise to K2CrO4 plus H2O. So this is the equation number 4. Here 2 moles of K2Cr2O4. Now calculate the oxidation states of each and every element. Potassium, this is the 1A group element, so plus 1 oxidation state. Oxygen oxidation state, that is the minus 2. This is the minus 2. Now chromium oxidation state calculate. So here how many potassiums are there? 2. So 2 into each potassium is the plus 1 plus 2 chromiums. Chromium oxidation state we are calculating. So put the x. So 2 chromiums, 2x plus 7 oxygens are there. Each oxygen is the minus 2. Then 7 oxygens means 7 into minus 2 equals to 0. Then 2 plus 2x minus 14 equals to 0. So 2x minus 12, this is the 2 minus 14, that is the minus 12 equal to 0. Then 2x equal to 12, x equal to 6. X equal to 6. So what is the chromium oxidation state in the K2Cr2O7? That is the plus 6. Chromium oxidation state is the plus 6. Next, here KOH, potassium oxidation state is the plus 1. Next, oxygen is the minus 2. Next, hydrogen is also plus 1. So these are the oxidation states. Next, K2CrO4, potassium oxidation state is the plus 1. Oxygen is the minus 2. Next, chromium oxidation state calculate. 2 potassiums, so 2 into plus 1, 2 into 1 plus how many chromiums are there? Only 1. So put the x. Next 4 oxygens, 4 into minus 2 equals to 0. Then 2 plus x minus 8 equal to 0. So x minus 6 equal to 0. Then x equal to how much? 6 only. This is. So chromium oxidation state how much? 6. Next H2O. In H2O hydrogen oxidation state is the plus 1. Next oxygen is the minus 2. So these are the oxidation states. Now observe potassium oxidation state in reactant side +1, in product side also +1, so there is no change in the potassium oxidation state, and chromium oxidation state is the +6, this side also +6, so there is no change in the chromium oxidation state also. Next oxygen -2 only. Next hydrogen is also +1 only, so there is no change in the oxidation state, so there is no oxidation and reduction takes place, so that's why it is not a redox reaction, not a redox reaction. So in the question what they're asking, which is not a redox reaction they're asking, so option number 4 is the not a redox reaction, so it is a correct answer for the question. Thank you.